Hello guys, today I'm going to be helping you revise over your permutations and combinations. In this topic, you're going to need to be able to recognize and distinguish between a permutation and a combination and know how to use the n factorial notation. Now I'm just going to brush over the definitions as I believe you've already done these, but I'll just brush over these just as a recap. Now first let's see what is a factorial. The factorial is the product of all positive integers less than or equal to a given positive integer, our n. N as in the total number of objects. This is given as the exclamation mark next to our n. So basically what this means is n factorial, as an example, is going to be n times a number less than n by 1 times the next number less than n times all the way to 1. We can give a quick example. 5 factorial is going to be 5 times 4 times 3 times 2 times 1, which is going to give us 120. 23 factorial is going to be 23 times 22 times 21 times ... all the way to 1. We don't need to calculate that, but you get the idea. Now we need to lay over some rules. First, a factorial is the product of all positive integers, meaning there can be no negative factorials. It will give you an error 2 on your calculator. You see? It gives you an error 2. So that's one thing to remember. Another thing to remember is 0 factorial equals to 1. Now I'm just brushing over this. I'm not going to show you exactly how to prove this mathematically, but it is an important rule of thumb to remember that 0 factorial will equal to 1. Now that we have factorial out of the way, we can define a permutation and a combination. Now permutation is the arrangement of a set. With a permutation, order matters. That's an important distinction. Order matters. So it's the ordering of a set, an arrangement of a set. That is what a permutation is. The formula of a permutation is NPR, where the P stands for permute. Our N is the total number of objects, and our R is the number of objects selected. The formula gives us n factorial over n minus r brackets factorial. Now we can move to a combination. A combination is the grouping of a set or combining of a set. Again, the important distinction is order does not matter. That is the difference between a permutation and a combination. Order does not matter. The formula of a combination is going to be NCR, or N choose R, C being for combine. Again, we know our N is the total number of objects. Our R is the number of objects selected, giving us n factorial over n minus r factorial times r factorial. Now we've gotten that out of the way. I'll just do some quick examples. Go to some questions over here. Let's look over the questions first. How many arrangements can there be of the letters GARDEN, garden, if, let's look at one, there are no restrictions? Now, What it means there are no restrictions as, it means this set or this set of letters here are taken only as they are, and there's no other factor determining how they are going to be arranged. It's only how many arrangements can we make with these letters. So, because it's talking of arrangements, then order matters. So this is a permutation. We're going to write it as there are 6 letters. There are 6 letters, and 6 of them are being selected. So it gives us 6 permute 6. If we use our formula, it's going to be 6 factorial over 6 minus 6 factorial. This will give us 6 factorial over 0 factorial. Now remember we said that 0 factorial equals to 1. So it's going to be 6 factorial over 1 or just 6 factorial. We calculate 6 factorial, it gives us 720. Okay, let's go to part 2. How many arrangements can there be of letters garden if it begins with GA? Now we've come to a restriction. Every time you have a question about permutations and combinations, we need to account for the restrictions. They should be the first things that we account for. So it says the arrangement has to begin with a GA. That means we can write this ordered set as 6 like this. Later on, it might take too long to write it as this, but learning and revising, it's important just to note and visualize it this way. It will begin with a G and an A. So G and A are already in place. They cannot be moved. So all we have to look at is the remaining 4 letters, R, D, E, and N. So since these are 4 letters, we can write this as 4 permute 4 or just 4 factorial. And this will give us 24. Part 3 says this arrangement does not begin with a GA. Now, if it does not begin with a GA, we can just say the number of ways in which it can be arranged in any way, which is our 6 factorial. This is how it will be arranged if it's no restrictions, minus all the ones that start with GA, which is 4 factorial, which is what we calculated before. This will give us 696. Okay. Part 4. It's asking how many arrangements can we have if R and E is together in order. So there are 2 things to note there. These R and E is together, they're together, and they're in order. So that means R and E, we can regard them as one letter or as one symbol. We have our G, our A, our RE as one thing, our D, and our N. So now we actually have 5 items now. We have 5 items now, 5 letters in our set, 5 objects. So this will be, this is going to be 5 factorial, which is going to give us 120. Now we'll go to number 5. How many arrangements can we have if the letters REN is together in any order? So now we have 2 things to note here. It's that REN is together, so that regarded as one object. And they can have any order. So these has to be ordered now. We have to find different ways in which we can order these. Okay, so again, we'll write them down. G, A, R, E, N, and D. These are now our 4 objects. G, A, R, E, N, and D. But REN is going to have its own arrangement. REN is going to have its own arrangement. So, okay, for REN, we just write a small REN. We have 3 places for these where REN can be. So now we know 3 places, or 3 factorial, it's going to be 3 factorial, which is going to give us 6. Move over here. Oh no, just move over here. For the rest of the letters, it's going to be, let me write the rest of letters. It's going to be 4 spaces. We're going to have 4 spaces. So it's going to be 4 permute 4, or 4 factorial, which gives us, let me see, 24. So our solution is then going to be 3 factorial, which is the number of ways REN can be arranged, times 4 factorial, which is the number of ways all the objects can be arranged, giving us 144. Now there are many examples of these for permutations. I would advise you to try as many as you can. I would advise you to try as many as you can, just to get it down. But for now, these are more or less the most common ones that you'll get. Then we'll move to combinations. We move to combination questions. Example 2. How many ways on a team of 5 players can 8 people be chosen from? Or let me read it as it is. How many ways on a team of 5 players can 8 people be chosen from? How many ways on a team of 5 players can be chosen from 8 people? Yes, okay, there we go. So now we look at number 1. If there are no restrictions. Example 2. If there are no restrictions, remember it's going to be, let me see, there are 8 people and 5 places for them, 5 selections we're going to be having. 5 selections we're going to be having. So it's going to be 8 choose 5. And from that we get 56. Okay. Now, part 2 says a specific boy, let me move this here. A specific boy, Cody, must be chosen in this team. Part 2, there's going to be a specific boy. Now what we've done to the set is we've removed one person from the number of people in our that we're choosing from. We've removed one person. And we've removed one space from the amount of things we are choosing from. So it's going to be here. It's going to be 7 choose 4. So which is going to give us 35. Okay. Now part 3. We have, hope you can see, a specific girl, Ray, must not be chosen. Again, we account for our condition. If we remove the girl Ray, we're removing one person from our set. So it's going to be, our n is going to be 7. Then we're choosing the same amount of people in our group. So it's still going to be 5. It's going to be 7 choose 5. (21). If we go to part 4, we'll read the second part. In this group, in this team, in this group, there are 5 girls and 3 boys. So we're going to form a group of 3 girls and 2 boys. Form a group of 3 girls and 2 boys. We're going to form a group of 3 boys and 2 girls. So we have to choose 3 girls out of the 5. So for the girls, we're going to have 5. From a group of 5, we choose 3. For the boys, we're going to have 3 choose 2. We put this together. 5 choose 3 times 3 choose 2, giving us 30. Sorry. Awesome. Now we have the last question, number 5, the last example. We have to form a group where there's a majority of girls. Now this is where permutations and combinations get a bit tricky, where we're dealing with things like and statements like and statements like or. So if we have statements like and, we are going to be multiplying, like here, we have 3 girls and 2 boys. But with statements like this, we can have this many girls and this many boys, or we can have this many girls and this many boys. I'll show you just now. But or is going to be a plus. We're going to be adding, and is going to be a multiplication. So in this case, it says we form a group of a majority of girls. That means we can either have the girls as being the whole group. This is 5, choose 5, because that fills up the group, right? Or we can have 5 girls filling up 4 spaces times times 3 boys filling up 1 space. Or we can have 5 girls filling up 3 spaces and 3 boys, filling up 2 spaces. And then beyond this, our condition no longer applies. It says we have to have a majority of girls, meaning more girls than boys. We calculate this to get times 2. Sorry. Choose 2. Aha. We get this, our answer, as 46. We get our answer as 46. Now, a lot of problems people have with permutations and combinations is the wording in the question. So the wording in question can really vary, and this creates an issue with how we order or what we count as restriction, whether something is repeated or not. It all depends on the wording. So if you do many examples, you'll find many different ways of how it's going to be worded, because Cambridge has very similar questions. You'll find very similar ways of wording, and you'll learn how to do this more easily without having to write so many things down. So I would recommend you looking through past papers, looking through different sources for various questions, word problems, so that you can kind of get the concepts down. But this isn't everything that you'll need to know, but for now, this is all I have time for. Thank you for watching.